Hello viewer, welcome back to my channel. We are moving on with our topic of uniform circular motion. In the last lesson we looked at centripetal acceleration, and in this lesson we are going to look at centripetal force. So please, let's get started. Okay. Now we are moving on. Centripetal force. From Newton's second law, we say that if you have a force F, a resultant force, remember R is a resultant force or net force. If we have that net force acting on a body of mass M, then it generates an acceleration A. Okay? Now, in our last lesson, we were talking about centripetal acceleration. So that centripetal acceleration is due to the resultant force which we are calling centripetal force. Okay? Centripetal acceleration is due to a resultant force, a net force which we call centripetal force. So today we are going to look at that centripetal force, and we are going to see how it keeps an object on a circular path. Okay? Now let's say you have a body. Okay, let's say you have two forces. If a body is going forward with a force Fa, then it will have an acceleration. But if you have a body going forward with a force Fa, or there is a force that is pushing the object, force Fa, and then it is acted upon by another force equal force Fa in the opposite direction, then the net force here, F resultant, is Fa minus Fa, because it is Fa plus negative Fa because of the direction opposite, which will give us 0. Okay? So practically there is no force acting on that body. Now, from Newton's first law, we say if a body was in that state of motion and there is no resultant force acting on that object should continue on that path, same straight line, on that path, straight line, at constant speed. Okay? There will be no change. Since there is no resultant force, acceleration is 0. What does acceleration is 0 mean? It means the speed of that object will not change. Why? Because there is no resultant force acting on that object, the resultant force is 0. So a body that moves at constant speed, has 0 resultant force acting on it. There is no force acting on it. That is very important. Okay? Now, what about if a body was not moving? If it was not moving, it was resting, and there is no force acting on it, then it remains resting. If a body was moving, and the resultant force acting on it is 0, then it continues at that constant speed. Okay? What if a body is moving with the resultant force is 0, so it is moving forward at constant speed? Okay? S. It's moving forward at constant speed S. And then another force acts on it. What would happen? A body is moving forward at constant speed, meaning there is no resultant force acting on the body. All the forces have cancelled. Now the resultant force is 0. So because the resultant force is 0, then it continues forward at constant speed. What if another force comes and acts on that body? What would happen? Now what would happen is the body will be deflected from the original path. If this was the path, then it will move, it will be deflected. So that now, if this was my object, if this was my body here, and then another force acts on it, then it will bend a bit, and now it will come there. So it will not continue. That was the original path. It will not continue on that original path after that force has acted on it. Okay? Now, if it was to continue along this path at the same constant speed s, and another force acts on it in that direction, then it will again be deflected, and that will be the new position of that object. If that continues, a force acts on it like that, while if no force acted on it, then it should continue along that path. Okay? But if a force acts on it, then again it will be deflected, and that will be the direction. And if we continue with this, then we are going to see this body moving. And what now we are tracing is a circular path. Okay? Okay? So this body started at a point, and remember, if it is here, it should continue like with the constant speed, s constant. Should continue like that, constant speed. When it is here, should continue like that at constant speed. So we are looking at a case where an object is being acted upon by a resultant force of 0, meaning there is no resultant force that is acting on that object. And that means, and this object is not stationary, this object which has 0 resultant force acting on it is in motion. If it is in motion from Newton's first law, it should continue on that straight path, same straight path at constant speed, because the resultant force is 0. Okay? So acceleration is 0. Acceleration being 0 means the speed is not changing, so it is constant. But if a force come and acts on that object, it will deviate from original path, and it will be deflected like what we have seen here. So the object is being deflected to new positions, and that is because of being acted by a force. Okay? Now if you look at the force that is acting on this object, that is moving at constant speed, that force is directed somewhere. If you take a good look, then we see that this force is directed towards the center of our polygon. Okay? It is directed towards the center. It is facing the center. The other thing we are noting about that force is that force is perpendicular to the direction of the velocity. That force is perpendicular to the direction of the velocity. Now, what if the force that is acting on our object is acting on the object very fast? Because whether we are going to trace a polygon or we are going to trace a circle depends on the rate at which our force is acting on our object. Then if the force is acting on our object very fast, then what we are going to trace are small paths which will end up giving us a circular path. Okay? They are polygons, but with so many edges. So we end up forming a circular path. Okay? If the centripetal force is very close and it's acting on our object very fast, then instead of having a polygon like the one we have here, we end up forming a circle with a center O. Okay? Now, this body, if there was no force acting, this force that is towards the center of the polygon or the center of the circle, if that force was not there, then what would have happened to our body? Our body would have continued on the same line, the original direction, without being deflected. So the reason why this object is going around the polygon or around the circular path is because of that force. Okay? Minus that force, the body should continue along the direction it was moving on initially. That force which is directed towards the center of a polygon or the center of the circle, that force is what we are calling centripetal force. Centripetal force is directed towards the center of the circular path. And it is the force that is responsible for a body remaining on the circular path. Without the centripetal force, the body will continue along the tangent. Now, as we are talking about a circle here, the body should have continued along a tangent. If it was here, it should continue along the tangent. If it was here, it should continue along the tangent. Now, that is minus the centripetal force. But because there is a centripetal force, then the body moves on a circular path. So minus the centripetal force, the body continues along the original path, which is along the tangent. Plus the centripetal force, the body moves on a circular path. So we define it as the force that keeps an object on a circular path. It is the force that keeps an object on a circular path, and its direction is towards the center of the circular path. Okay, so that is the centripetal force, and that is what we are looking at today. So we have started by saying, what is a resultant force? Forces are vector quantities, so we add them up if they're in the same direction, we subtract them if they're in opposite direction. When all the forces acting on an object add up and cancel out, we have one force that remains, and that force is called the resultant force. And a body will always move in the direction of the resultant force. In Newton's second law, we say when a resultant force F acts on an object of mass m, it gives that object of mass m acceleration a. What does acceleration mean? Acceleration means the speed of the object increases with time. But what if after the forces have added up and cancelled, the resultant force is 0? What happens now? What happens if a body is stationary, it remains stationary. If a body was in motion, it continues in motion, but at constant speed. That's very important. Now, for a body that is moving with constant speed, what would happen if another force acts on that body? The resultant force is 0, but another force comes now and acts on the body. Okay? Now, what happens is the body gets deflected. From the original direction, it gets deflected. And so the new velocity now changes. That was the direction of constant velocity. Now that is the direction of constant velocity after being acted upon by that force F, which is our centripetal force, CF. Okay? Now when it is here, it should continue in that direction at constant speed. But again, the centripetal force again acts on it. And again, it is deflected. So these angles here, the angles of deflections, those angles are all equal. And because of that, the body keeps on deflecting and deflecting and deflecting until we go back to where we started. So the centripetal force first is the one that causes the deflection. 2, it is directed towards the center of the circular path. 3, it is perpendicular to the direction of motion of the body, to the direction of velocity. And 4, it is the one that maintains an object on the circular path. That is very important. So today we have looked at that centripetal force. Now, according to Newton's second law, therefore that centripetal force is equal to what? Mass times A. What is A? Centripetal acceleration, which we said is V squared over R. So centripetal force, we give it as mv squared over r, where m is the mass of the object, v squared over r is the centripetal, is the acceleration, centripetal acceleration. So a body will accelerate on a circular path when it is acted upon by centripetal force. We call that acceleration centripetal acceleration. Okay, so let's look at a question here. Saying a body is an example. So a body having a mass of 0.5 kilogram is tied to a string and in a horizontal circle of radius 2 meters with a speed of 3.16 meters per second. Stop. So calculate the centripetal acceleration and B, the tension in the string. Okay, so we have that question. So this is a body moving on a circular path. I want to draw it here. So radius is 2 meters and it is being pulled to the center. Let me put it there. And it is being pulled by the string. So the string is being pulled towards the center. So that's what we call the tension. The tension is the force that is pulling the string. So what is the tension in that string and what is the centripetal acceleration? So we know centripetal acceleration is V squared over R. So what do we have? It is moving at 3.16 meters per second, all squared, divided by R is 2 meters, which gives us that's 9.9856 meters squared per second squared divided by 2 meters. So divided by centripetal acceleration equals to 4.9928 meters per second squared. Remember this 2 meters, meter cancels with meter, so we are left with the meters per second squared. That is part A. So B, the tension, we said centripetal force is towards the center of the circular path. And the tension, if you're moving the string around, the string round holding the object, it is the tension, the force that you are pulling the string with towards the center that is maintaining that object on the circular path. So the tension simply is, we are calculating centripetal force. So F, centripetal force, is equals to m v squared over r, which is mass of the stone, mass of the object is 0.5 kilogram times v squared over r, we have already calculated as 4.9928. Let's watch it then. So which is equal to which is 2.4964. Of course, is kilogram meters per second squared, that is newtons. So that is the centripetal force. Okay? So from that, we are able now to calculate the tension in the string, which is our centripetal force. Remember, there has to be the source of centripetal force. And the source of this centripetal force is an external force. It could be the tension in the string. It could be gravitational force. It could be frictional force. It could be anything. It is an external force acting on an object. As long as it's directed towards the center of the circular path, it is our centripetal force. In our case, in this question, our centripetal force is the tension in the string. What is the tension? The force with which you are pulling the string. That is your centripetal force. So this part B here, we have calculated it there. So the first one, we have calculated centripetal acceleration, and which is that. And then we have applied in the part 2, part B of the question, to calculate centripetal force. So I hope you have understood centripetal force. That brings us to the end of our lesson. Thank you very much for watching. Don't forget to like, to subscribe, and don't forget to share this information with those people that really need it. Until the next lesson, goodbye.